Okay, we've been talking a lot about different things about circles. One thing I want to review real quick is we'll do a circle here just to review it and say, okay, if I have an inscribed angle, remember, is an angle that goes across the circle like this. If this arc here is 60 degrees, the central angle, the angle that would go here, matches at 60 degrees, but the inscribed angle is 30 degrees. Well, you notice the diagram I've drawn over here actually has a tangent line, which I'll mark in blue, and it has a chord of the circle, which I'll also mark in blue. So I can take that tangent line and that chord and notice some things about their properties. One thing you'll notice is that this arc here, which MAB, from A to B, this arc would be 130 degrees. And this angle in here is 65. So just like this inscribed angle is half of the arc, the angle on that tangent, since it's kind of like an inscribed angle, since the vertex is also right on the circle, kind of like an inscribed angle, it's also half of its arc. Now, one thing that'll show up in a problem like this with these tangents, though, that doesn't show up with the inscribed angle, is they could actually ask you to find out this angle on the backside. They could ask you to find the value of angle ABC. And at first glance, you might think, I don't have any way to get that information. Well, there's several ways you can get it. Sometimes, if you know this angle right there, it's as simple as subtracting that angle from 180 degrees. But if you don't have that angle there, let's say they just didn't give you that, you have two options on how to solve this problem. One way is I can say, well, if this is 130 degrees, if this piece of my circle, this arc is 130 degrees, I could take half of that and get the 65 and then subtract from 180. That would work. Or the other way you could do it, you could say if the green arc is 130, the red part of the circle, the red arc, is 360 minus 130, which is 230 degrees. So not the angle, but the arc is 230 degrees. And now if this arc here is 230 degrees, angle ABC, what I really wanted, the amount in the middle there, would be half of 230, which is 115 degrees. Which, of course, if I had the 115 plus 65, that would make 180 of a straight angle. So you got lots of options on how to solve these problems. Just be aware that you can either use the circle and the fact it adds to 360, or the straight line and the fact it adds to 180. And the third fact that the arc is twice the size of the angle, or the angle is half the size of the arc, however you want to look at it. Now, let's go ahead and look at a different type of intersection that happens. And that is if you have two chords intersecting in a circle. Now, I wanted to show you this. I have AB, which I have marked the measure. This program kind of forces it in the middle. Arc AB is 60 degrees right now. And then right now, arc CD is 40 degrees. And notice the angle in the middle is 50 degrees. And it is not a coincidence that 50 is exactly in the middle, because one property that is true here is it's not an inscribed angle, but the angle between chords, or the angle of intersecting chords, is equal to the average of the arcs. And of course, to average the arcs, I can take arc 1 plus arc 2 and divide it by 2. And that's going to be the intersecting chord angle there in the middle. So it's no coincidence that if I were to do 60 plus 40, that would be 100, divided by 2 would be 50 degrees, which matches that angle in the middle. Now, I'm going to erase these marks I just put and show you that even as I move and change the size of these angles, that property is going to remain the same. Because what we can see is if I were to drag one of my points, like right about there, I have both arcs that are 60 degrees. Well, the average of a 60 and 60 is 60. So that means the angle where they intersect is 60. If I continue to make this arc bigger, maybe I make it close to 80 degrees. You notice that gives me 80 and 70. The average of 80 and 70 is 60. You might say, well, does it always have to be 60? No, it doesn't. You could make it smaller, and I could do, for example, if I had 80 and 60, that would give me a value. I'm sorry, if that's 80 and 40, that gives me an angle of 60. Or if I had something like that, that gives me an arc of 60 and an arc of 80. That gives me 70. Because once again, if I were to average these, I would have 60 plus 80 divided by 2 is equal to 70. Now, there's several things that you can be asked to do in a problem like this, and we'll work a couple examples in just a second. One other thing I want to show you, the other thing that can happen is I can have this situation here. And this one is different because instead of talking about an angle inside of the circle like I have when I have chords, I have an angle outside the circle. And this can be formed by a secant or tangent. So it's an angle formed outside the circle. So I'm just going to call it an exterior circle angle. Technically, it could be either two secants or two tangents, but it's the exterior circle angle is going to be equal to the difference in my arc divided by 2. So it's going to be my big arc minus my little arc divided by 2. So I'm going to have my big arc minus my little arc divided by 2. For example, if I look at here, I would say my big arc would be 108 degrees. My little arc would be 54 degrees. And then I can do 108 minus 54 and then divide it by 2. And 108 minus 54 would be equal to 54 divided by 2 would be this value of 27. So there are several different properties here. Notice if you have the outside angle, you subtract and divide by 2. When we had the inside angle, we added and divided by 2 to get the average. And when we had a tangent angle, it behaved just like an inscribed angle because it was touching the circle. So lots of different things about circles. One piece of advice I want to give you, though, as we start to set up a few of these problems, is just kind of use your use common sense. If you draw the circles to scale, a lot of times you will catch a mistake. Like if you mess up and add instead of subtract, you'll figure out, hey, this angle says it's 80 degrees. There's no way that angle could be 80 degrees. It looks much bigger than that or much smaller than that. So be sure that you're just using common sense to double check these formulas because it is easy to slip up and use the wrong one at the wrong time. Let me clear these marks off and we'll show you a couple problems like what you're going to be having in the book. On the first one I want to show you is going to be a lot like those first few problems. So I'll think this diagram is the closest to what we need. So what I need to have is a diagram set up something like this, and they've told you in this case that you have an angle here of 70 degrees. Now, a lot of interesting things I can find out. If this is 70 degrees, like I said, we can use the fact that these add to 180 to figure out that that is 110 because they make a straight angle together. So 70 degrees for angle B is the letter in your book. ABD is going to be 70. And then this is 110 is equal to angle ABC. So two angles there. And then we could find both of the arcs. I could find my minor arc, my arc AB. Once again, since that angle is basically on the circle, it's not inscribed because it's formed by that tangent, but it works the same way as an inscribed angle. So if that is a 70-degree angle, this arc here is 140 degrees. And on this side, if this is 110, this arc would be 220 degrees. And you could check your work by saying, does 220 plus 140 really equal 360? And it does, so you know everything works out. Good common sense. Okay, and this one is one where we have the exterior angle. And I'm going to set this up a little bit like number 9. I think most of you, if I told you that this piece here was 4x plus 8, and that this piece here was 3x plus 2. You could recognize this as I had a big arc here, and I had a little arc there. So if I had a big arc and a little arc, that would come out to be 28 degrees, like that. So what I could do is I could select some points. But what I want to show you is, as these points get closer together, I still have a big arc and I still have a little arc. The specific sizes might change a little bit, but even once those 2 points are basically in the same place, and once again, I could move this a little bit this way and this a little bit this way, I still have a big arc and a little arc. So even if those things are actually tangent, I still, if those 2 points are tangent to the circle, still have a big arc and a little arc. So I still have my big arc here that goes all the way around from A to C, and I have my little arc there that goes all the way around the other way. So to set it up, whether it's a secant or whether it's tangents, it's still a situation where you have an external angle. So you do your big arc of 4x plus 8 minus my little arc of 3x plus 2 and divide it by 2 to get my little angle, which in this case is supposed to be 28. Now this is going to create a little bit of an equation, and it might be best if I put parentheses around those to help us. So I can do 4x minus 3x, looking for like terms, so that gives me an x plus 6 divided by 2 is 28. And then if I need to get rid of my divided by 2, I say what's the opposite of division? It's multiplication. So 56 is x plus 6, and then subtract 6 from both sides, so x ends up being 50 degrees. And that gives you a way to solve that. And like I say, the same thing would work whether the diagram looked exactly like it did on number 9 or whether it looked more like it did on number 7. In either case, you can set up an equation using the fact that the big arc minus the little arc equals the angle, put the variables where they go, and use your algebra and trust your answer. One last one I want to do, which this one's set up a little bit more like, I'm sorry, that one I just did is more like 8 or 9. This one is going to be more like 6 or 7. If I'm looking at this, let me clear off so my letters might be a little bit different, but this one I'm going to set it up a lot like number 6, where I have, if this side is 50 degrees for this arc here from A to B, and this arc over here, you got an arc over here that is 92, and it wants to know this angle in the middle. Well, once again, just this time, since it's in the middle, I add the arcs, 52 plus 92 divided by 2, and that would give me an answer of 142 divided by 2, which is about 71 degrees. And 71 looks like a reasonable estimate for that arc looking at our book there. It looks somewhere a little bit bigger than 60, not quite a right angle, so 71 degrees seems reasonable. The reason I point this out is one of the most common mistakes is you might mess up and subtract. And if you were to subtract, you would have gotten an answer of 42 divided by 2, which is 21 degrees. A 21 degree angle is teeny. That would have been an angle that was about like that, almost like a pair of tweezers. So you can tell looking at your diagram, if your diagram is drawn to scale, you can trust it and say, hey, that can't be the right answer. I must have made a mistake. I should have added. And that's how I got that. So I hope this helps you know how to set up these problems. If you have any questions, don't hesitate to ask.